Hello students, welcome to Math Beyond Marks channel by Professor. Here we understand concepts first and marks follow automatically. This is video number 8 in our class 8 CBSE Maths playlist, chapter 1, a square and a cube, new syllabus. In this video, we are going to solve all the questions from the figure it out exercise in the book. Remember, there is no exercise like that separately like previous years. Now they gave it as figure it out, try it out like that. Using the patterns and methods we discussed in the previous videos, we are going to solve those sums. If you haven't watched them yet, I strongly recommend watching them first, because today we are going to apply those concepts in this video. Shall we go to the video? This is figure it out exercise from your new textbook. It is not given as an exercise. We have to solve these questions from the previous basic concepts what we have learned. Okay, let me see. I made this into some topics. Identifying perfect squares. Under the two questions, which of the following numbers are not perfect squares? What is it, not perfect squares? How to find? We have seen while doing patterns. You have seen one square ends with 1, 2 square ends with 4, 3 square ends with 9, 4 square ends with 16, 5 square ends with 5, 6 square ends with 6 again, 7 square ends with 9, 8 square 64 ends with 4, 9 square ends with 1, 10 square ends with 0. So other numbers not there. 10 square ends with 0. So these are the numbers. Here the numbers 2, 3, 7, 8 are not present. Hence, if there is a number and say that is a square number and ends with 2, 3, 7, 8, it is not a perfect square number. So the first one is not a perfect square number. 8, it ends with no, it is also not a perfect square number. Next, 1027, no, it is not a perfect square because it comes under this category. And 9, it comes under this category, but we can say that it may be a perfect square or may not be a perfect square. We cannot say compulsory it is a perfect square. For that and all, I have seen the examples in the patterns. If you have not seen, please watch that video and come back. Which one among the following has last digit 4? Okay, the same thing. 1 square is 1, 2 square is 4, 3 square is 9, 4 square, that one. Based on that, 64 square. So number 4 square will end with 6. Okay, this ends with 6. Then 8 square ends with 4. 2 square ends with 4, 6 square ends with 6. What they're asking now here, which one among the following has last digit 4? As last digit 4, yes. Here the numbers 108 square and 292 square are ending with 4. This is topic number 1. Okay. Second topic is using square patterns. Okay, 125 square is 15,625. Find the value of 126 square. This you have two methods. Follow one method what I taught in the pattern method. But now I am going to use a new method. You know, this is 125 square. So let 125 be A. Let you assume this as A. You know A plus 1 is 126. That means if I want to find the square, then it is nothing but a square plus 2a plus 1 identity I am using. That is, a square is 125 square plus 2 into 125 plus 1. This is the logic. That means 125 square we know 15625 and 2 into 125 is 250, then 1. So now total the answer is 15871 is the answer for 126 square. So 126 square equal to 15871. Okay, let me check once again. 6, it is not 1, sorry, it is 6. Okay, it should be 15876. Okay, next, find the length of the side of a square whose area is 441. They say yesterday in previous video in patterns we have seen if this square is divided into 9, and that means this is having 9 squares, their side is nothing but 3 3s are 9. So if the square of 3 is 9, then the square root of 9 is 3. Likewise 441, if you know up to 30 squares if you wrote, you can find out easily. It is nothing but 21 square, or you can use prime factorization method. Okay, now what is the LCM for this one? 2 into 3 into 2 into 3 into 5, because all it ended with the prime numbers. Hence LCM is the product of all the leftover prime numbers. That means 2 into 3 into 2 into 3 into 5. Okay, so that is nothing but I will take 2 and 5, 2 into 5 as 10. 3 3s are 9, 9 2s are 18, 18 into 10 is 180. Now 180 is divisible by 4. Yes, 4 4s are 16. 2 remainder 20, 4 5s are. So the number is 45. This is the smallest number, okay. But what they're asking, square number. Is it a square number? No, it should be divisible by. Now, look at this one, how to evaluate that. Look at this. This is having a pair, and this 2 is having pair. Only one number 5 is not having a pair. So what I am going to do, 180 I am going to multiply by 5 to get 5 0, 5 18s are 90, it is 900. That means not 180. Actually, according to last year's syllabus, LCM, that is correct. 180 is divisible by 4, 9 and 10. Is it square number? No. So least square number means this is the 900 is the least square number which is divisible by 4, 9 and 10. Why I took like this means because one number it is not having a pair. See how that patterns are working out, and pairs are very important. That's why if pair is not there, this pattern, this sum is not going to end. That's all. So what is the answer for this one? 900 is the smallest square number. Is it a square number? Yes, because all are having pairs. No, surely it must be a square number only. Next, question number 6. Find the smallest number by which 9408 must be multiplied so that the product is a perfect square. Also find the square root of the product. Okay, let us see. What is that 9408? Okay, 9408, we will take this number and use prime factorization for this one. 2 4 times 1 7 0 4 4704. Here again 2 table. Okay, 2 7 means 3 times, 1 remainder 10 5 times and 2 times. Again 2 table. Yeah, 2 table means we have to feel happy, 2 or 3. Okay, 2 12 not 11. 11 sir 22, 1 remainder 15, 4 7 times 14, 1 remainder 2 6, 1 1 7 6, again 2. Okay, 2 5. Okay, 1 remainder 17 means 2 8s are 16, 1 remainder 2 8s are 5 88. Again 2 table. 2 4 sorry 2 times 4 and 1 remainder 9 times and 4. Again 294. Again with 2 table. 2 14 sir 28 and 1 7 147. Here came the even odd number, so not possible. 1 plus 4 5, 5 plus 7 12, so it is possible with the 3 table. 3 4s are 12, 2 7 9. Okay, then you know 7 7s are 49. Here you see this numbers is 2 and 2 is having a pair. 2 and 2 is having a pair. This 2 and this 2 is having a pair. 7 and 7 is not having a pair. Only 3 is not having pair. So this 9408 is not having a pair. Hence it is not a perfect square. So what number must be multiplied? It should be multiplied by 3. Into 3 if you do, then you will get the square number. That number you will be getting. You multiply it and get that number, because it will consume time if I multiply here. Okay. Next, how to find the square root of the product. The product means you'll get one bigger number. Don't worry about that number. Here the pairs are what? No, 2. One number is 2 into one more 2, this 2, and for this one 1 2 and 1 7 and only 1 3 extra we are taking, that's all. Now you have to multiply. 7 3s are 21, 21 into 2 42, 84, 168. So you will get one number, no? For that number square root is number equal to 168 is the answer. So what number here? If you do prime factorization, that's all over. At the end of the prime factorization, you are going to check whether all the numbers are having pairs or not. Either if we divide this number also, you will get a square number only. Perfect square number you will get. Either you can divide it, remove it away, or you can multiply this also. We have seen with small numbers in patterns. Now practically in the exercise they gave it larger number. Your next question in this exercise is, how many numbers lie between the squares of following numbers? You know, in patterns this you have seen. If 16 square, they are asking like the squares of the following numbers. 16 square and 17 square, how many numbers are there? There is no number, no, not like that. 16 square is 256. 17 square is 289. Between these, how many numbers are there? You have to go on counting 257, 58, 59, 60, like that. Not possible. For that only we wrote one. We got one pattern, that is nothing but 2n. N where n equal to the first number. If 16 and 17 means 2n, that is 32 numbers will be there between these two. You subtract it. Okay, subtract 289 and 56, 256. 256 if you subtract, one problem will come. 3, 8 minus 5, 3, 0. 33 numbers will come. Why? Because while subtracting there is a practical difficulty. This number or this number will be included. Okay, from 289 you are going to subtract 289, but 289 you are starting. So here they are asking only the between, starting from 257 and up to 288, not 289. So between numbers, therefore not 33. So if the numbers are larger, use this technique also. What is that? Subtract it and just subtract again one number, then you will get that one. Or here you know, no, 2n numbers, 2n 32. Then what about 2n here? 99. 198 is for second one. That's all answer. So 198 numbers will be there in between 99 square and 100 square. My dear children, this many sums I did as example sums from exercise. Still few more sums are there. You try it out. In that sums, if you have any doubt, please let me know in the comment section. I hope you all liked this video of solving exercise. This is not a big thing. It is being done already. Just I solve the exercise. If you like this, please comment it. If you are watching first time, please subscribe and share to your friends also. Let us see in the next video. Till next video, it's bye from your Pragasam sir.